We're going to continue on, but let's just revisit the last example. I'm going to take a look at x squared minus 2x. What constant would I need to create a perfect squared factor? The answer is I take half of negative 2 and I square it and I'm going to add it. That's what I would add. So I take half of this number here and I square it. So negative 1 squared is 1. So that's what I would add. And you can see if you factor it, this factors into x minus 1 squared. Let's add another layer of difficulty. Well, it's actually the same level of difficulty. Suppose now I have a non-even number. Now that changes things a bit. So what number would you need to add? I'm going to give you the heads up. Dividing by 2, normally we take half this amount. And we can say, well, I'm going to take half that amount, which is 5, and 5 divided by 2, and then I'm going to square it. We could also take negative 5, and we can multiply it by a half. These two are similar or identical operations, really. So I would take negative 5 halves, square it, and that is 25 over 4. That's the amount that I would add to create a perfect square factor. And if you factor this, this will create a perfect square factor of x minus 5 over 2 squared. Last but not least, well, what constant would I add to create a perfect squared factor? I'm going to take the coefficient. There's a silent 1 in front of that x, agreed? So I'm going to take half of 1. I'm going to square it. 1 times a half is 1 half, and I'm going to square it. 1 half squared is 1 quarter. So I'm going to add 1 quarter. If I add 1 quarter, I'm able to factor this into x plus 1 half squared. You may be asking yourself, how is he able to factor this so quickly? Well, there's a few things. Remember the number that I squared? The number that I squared is, in fact, the constant. So, by the way, what we've been doing here by adding a constant is actually not serious mathematics. You can't arbitrarily add a constant to an expression or an equation or a function without having to sort of compensate somehow. You cannot just add 1 to one side of an equation. You have to do it to both sides of the equation or somehow maintain that balance. So this brings up the issue to change the general form y is equal to ax squared plus bx plus c into Vertex form y is equal to a open brackets x minus h squared plus k. We must complete the square in the context of the function. With expressions, equations, or functions, we must always maintain equality or we must not change the value of an expression. So please jot down some notes when you're doing this to help you in the future.